So today we have a subwoofer by Stellar Labs to look at. This came from a friend at work, and this is a complete, almost brand new unit here. So this one was sent to me just to show what it goes in and how it comes apart, and also for testing later. And we have 10 hex screws around the perimeter to get this amplifier from the rear of this subwoofer, and it disconnects from the board like so. And this is the faulty one that is just like it. So my friend had this one power on an external sub, and now the power just won't come on, so he just wants to take a look at it and fix it today, so we know it don't power on. And looks like 120 volts comes into this board up here and then outputs to the toroid. Yeah, looks like it goes out. So we're going to be looking at this part here. Because my friend is really good at fixing things himself, he's already checked the switch, he's already checked the fuse, he's even torn to the transformer here to make sure it wasn't some kind of thermal. He's definitely seen that before, like many of us, and he decided to bring it in with the other subwoofer so we could test it out if we do get it repaired. And we can see here that we have solder connections but no thermal here, by the way. We'll put some Kapton tape around here when we're done. But we do see a power LED here. It's clear, so we don't know exactly what color it should be. Let's just plug it up and verify on camera that it does not work. And we're on, off, on, and no light, no flicker of any kind. So let's go ahead and be very careful here, and always be careful with mains voltage. Never work around or troubleshoot mains voltage if you're not qualified to do so. So I'm just going to make sure right here, and yep, we are getting 120 volts straight into this board. Let's see what we got going out to the toroid. And really nothing. Just a little bit of induced voltage there, nothing. It's making it across. So if we go to the neutral side here on this connector, looks like we have a thermistor here. We'll make sure we're getting across. Yeah, let's see. Yep, 120 volts. Going to a 4 individual diode bridge here. We'll just go straight to the capacitor itself. And there we go, right at 163 volts on the cap. So our incoming DC bus is good. We know that we're not switching from this relay right here. So it's more likely going to be in this converter circuit right here. It's a little switch mode that fires this relay. And of course that relay outputs the 120 volts to our toroidal transformer. And if we check on this cap on the lower voltage side, we get nothing. So as suspected, we got a problem in this area here. We're going to unplug, cut it on and off, and just make sure our capacitor does have time to drain down. Before we go too far troubleshooting, it's probably wise to at least check these higher current or active devices, our complementary set of amplifier transistors. I'll shine a little bit of light in here. I can't tell if that's showing up on camera good enough, but these are going to be fairly large transistors. Get a little bit closer here. One cool thing about this board, they do an excellent job screen printing. As we see the A1943, we know exactly what this transistor is without even having to get to it. And on the other side, we have the complementary C5200. And I will put some data sheets up here during editing, and these will probably show as complementary to each other as well. I'll try to show that. Give you a little bit better view here in case that other light was not quite sufficient. See them there on the heat sink, secured really well. Looks like a good amount of thermal paste, and tightened down to the heat sink. It looks awesome. So really quick, let's just look at how good the screen printing is here on this board as well as this top board. We could tell Advanced Acoustic did an excellent job You just don't see that as much today, so I'm spending a little bit of time here just appreciating and bragging on them because it's so helpful. Even the part number on some components and values are on the screen printing. Let's go to diode mode and let's just do a quick check and make sure we don't have a short. I'll throw the data sheet up here if it's helpful. At the time of this troubleshooting, I'm just going across, see if I find a PN junction that is not shorted. And absolutely that looks good. I'm just going to take my negative lead over to the left. Good. We'll go over to the other transistor. One's going to be NPN and one's going to be PNP. So I'll just swap the leads around. Hadn't looked at the sheet to even see if this is right, but just looking here for a PN junction. And yeah, we got it one way. Yep, we got it both ways. No short, so that's a good sign. That's really as far as I want to go with this until we get the power. Just want to make sure it's a reason to keep going, because those components can get a little more expensive than these smaller ones. So we've already made sure we had our DC bus here. We do have an optocoupler. As you'll see, it's bridging this gap between our high and our low side. So this is a separator, and of course the relay is a separator. And we have a really nice isolation slot here. So it's a very clear indicator of our high and our low side. So these two transistors right here are the first thing I want to check in this part of the circuit after verifying power to it. And we are in circuit, so we can't guarantee a correct reading here, but really not happy with that reading. The transformer's primary is also on the output, so definitely could be skewing the results. But then we seem to open on 2 pins as well, and that's very odd. I would say more than likely this transistor is faulty. And if we go to the smaller transistor here just down below it, I can't get a reading at all. And even though this is in circuit, we know that it can be skewed, but it shouldn't be open. I mean, if the transistor shows open on these pads, it must be really open, because of course the circuit will just add impedance, not take it away. Let's go to the top of the board so maybe you can see what I was doing maybe just a little bit better. I was going across the pins of this one here, and as you can see, we don't have anything in diode check. And then this larger transistor, we get a fairly low reading, which the transformer here could be causing some of that. But then we get an open on the other side. That's really pointing to a bad component, really. So that's why we're not getting our 120 volts out to our transformer. Oh wow. Let me know in the comments if you've seen it on video before I did, but this transistor was tilted down, so I didn't even see until I went to look at the part number that the whole face of this transistor is actually blown off. So it just happened to be tilted that way, and I really didn't pay attention to it at that angle. I saw the part number on the board and thought that was really cool, 9014. I was just going to verify that the front did say 9014, and good thing they marked the board because the face is totally gone. So thank you, Advanced Acoustic. That's awesome. So the first thing I'm going to do here is just quickly remove the small transistor, and I could take this board out and get it under the microscope and possibly remove these wires and get a better work area, but I think I'm just going to try to quickly remove this and see if we get lucky. I do have a pretty decent 993A desoldering gun, and it works excellent for through hole. It really does, but it will absolutely block everything I'm doing in video. So just going to go through here with the braid, maybe the solder sucker every now and then, and remove some of this. I could have used a solder sucker to pull some of this off. I'm not going to mix low melt with it because being through hole, it's going to be no problem, and it's out just like that. No problem. Now I just so happen to have a handful of these that will probably work just fine. These are BC547, so they do show up in the technical specs for the 9014 to be a replacement or equivalent. So I'm definitely going to go ahead and put one of these in. Bend the leads a little bit so hopefully it'll sit straight. Put some more flux on here. I'm going to use some leaded solder to solder this back. And reposition a light here. Maybe it'll help the footage. I'm not sure. I can see pretty good, but the camera looks a little bit dark. Sorry about the shadows. Put a little bit more flux on here and see if we can make this look decent. Alright, let's cut the leads off. Try to keep any from being a projectile. Let's clean up. Going to use a Q-tip. We'll also use the brush. And there we go, that looks good. Alright, let's go ahead and give it a try. Nope. Oh, I can smell something getting hot. Oh, yep, see it. You see the smoke? See if I see anything here if I bump it back on. Oh yeah. That's a telltale right there. Yep, it's going to be the resistor feeding that transistor. So guess what? How many of you already knew that I should have flipped that transistor around the other way? So this is a rookie mistake right here. Rookie mistake. So it was definitely an equivalent transistor, but I didn't follow the first rule of making sure the pinout is the same, because we've all seen it. I really don't deal with the TO92 package as much as I used to. So many of the surface mounts are not this way, you know, but you kind of forget that these older style transistors, a lot of times they would be different pinouts even if they was equivalent or comparable. With the 9014, we were 1, 2, 3 was emitter, base, and collector respectively, and of course my replacement 547 is collector, base, emitter, so I should have swapped it around. So I had plenty of them, but it also took out that resistor. It could also be bad to have a resistor burned up like that if you didn't know the value. But two things here. We had the video footage from earlier that I'll show on the screen that sometimes you just don't have when you need it. As you can see in some of the components, they actually screen print underneath, and they even give the value. So how awesome is that? So let's replace this resistor, and I have one right here. It's a little bit higher wattage, but it is a 3.3K as shown here on the tester. So we'll snatch this resistor out, as well as replace the transistor and switch it around. I'll get my solder sucker in here if it ain't blocking the camera too bad, and I'll just simply remove some of this solder just so it ain't so much on the wick. I still have a couple feet of wick left, but I'm getting a little bit low. And is it loose? Yep, it's loose. We'll also go ahead and pull out the transistor, which will be a little easier with the leaded solder. And there we go. So we cleaned up here. Let's clean up the top and show you right quick here. You see that 3K3, pretty awesome. And here's our transistor that goes the opposite way shown here. Awesome. Yeah, we'll make sure it's flipped. I'm going to have to squeeze in these leads just a little bit, and that's going to leave this resistor a little bit higher above the board, which I really like that. It gives it more air and cooling. Won't run quite as hot, so that's going to be just fine to me. We're going to put on some more AMTECH 559 Flux, and I'll have links down in the description for a lot of the supplies and tools that I like to use if you find it helpful. It'll be in the video description, so make sure you look for that. Let's go ahead and tack these on here really quick. Cut some of the leads out of the way. a little bit more flux here, and let's go ahead and finish up. And there we go. Let's clean up. Cut the remaining leads off. So we did the resistor here and the transistor here. We'll go ahead and clean some of the flux that came through on the top side. And we see our transistor is backwards, and we have our new resistor here. Still may have a problem here on this part, but hopefully our optocoupler for feedback is good. They rarely go bad. Just going to look here with the thermal camera as we bump the power on and off. And yep, something got hot really quick. I think it's the same resistor. I'll show you the actual footage so you can see it a little bit better. The parallax is off a little bit on my infrared camera with the phone image, so it's showing us a little bit high. So it's right there at that 3.3K resistor we just installed. We know our transistor's good and in circuit right. So I would say it's definitely going to be that larger transistor that we already did question. So let's just remove it really quick. This is going to be the TO126 package. It's going to be a 13003 base collector emitter 1, 2, 3 respectively. And if we put this in the tester, did it show like we thought, or was it showing that way because it was in circuit? That was definitely a dead short on 2 to 3 and open across 1 to 2. Wow. So I do have to order the 13003. So the video will resume after these come in. Back now, I do have a couple new of the 13003. This is going to be exact replacement, so it can go in the same way it came out. Just so happened the board showed the line on the left like it may have had the heat sink that way, but these are turned the other way from the factory, like so. But you see here on the right it shows E1 and then 3003. So it even gave us the part number on the board for this one as well. Let's go ahead and move these wires out of the way so you can see it a little better, and I can get to this one a lot better. We got our AMTECH 559 Flux on here, and we're going to put back on the leaded solder, and we'll see if we're good to go. Awesome. Go ahead and clean up. Cut our leads. Let's test it out before we put the power on it. This is what our small transistor reads like. That looks like what I would expect it to read. But I do want to test this resistor. Since it was a dead short on this transistor, it actually looks okay. But this is a very low ohm resistor. Just want to verify here before we put the power on. It looks like this might be a 10 ohm resistor. Well, we're getting almost 500K, so let's look a little closer. I don't know if you can see it on camera that great, but we are brown, black, black, gold. So yep, 10 ohm, 5%. So even though this resistor does not physically look bad, it is opened up. Let's go ahead and remove it really quick. Get our solder sucker, suck some of this off, and put some flux on here and get our wick some of that lead-free solder off of there, and there we go. We're out just like that. And I was guessing this was a 1 watt resistor, and right here it tells us plain as day 1 watt 10R. Awesome. So I'm going to leave this resistor off the board just a little bit for cooling, like so. And we'll solder this back in real quick. We'll put our flux. Get some more leaded solder. There we go. Do a little cleanup. Snip off our excess leads. So we go to ohms now across this spot. Yep, around 12 ohms. Good deal. These meter leads have a little bit of resistance, so that's fine. Let's do diode check here across this transistor. Yep, we do have a PN junction there. And 1.1 across there where the transformer is. Awesome. Alright, is it going to work this time? Let's plug it up. I feel a lot better about it this time after replacing most of the things that we thought may have been compromised. There we go. The light's blue. How about that? I would have guessed green or red, but awesome. That got it. I'm going to unplug it. I'm going to take some Captain tape and put around this transformer, especially to protect those solder connections there on the secondary leads in the blue that feeds the power to our amplifier board. So back now with it installed in the subwoofer case. I could feed it some audio, but I'm just going to take some bodged up wires here and come off of my signal generator some low frequency signals. We're going to start like 2 or 3 hertz. This is just an old analog function generator. And if everything's working good, we'll get a little bass out of it. We'll start off low. We want to keep it somewhere probably not much over like 150, 160 hertz. We're going to plug this in and we're just barely going to turn this up because this thing will probably rattle my window in this little office. We can change our frequency a little bit. Yeah, we don't need this turned up much at all. We can play around with the symmetry, the offset, amplitude. We can even do a sweep. The sweep might be kind of fun. You can change width and rate. If we pull the rate potentiometer out, then it's logarithmic. I know the digital display is really laggy on this thing, but you can tell in the sub it's sweeping through pretty good. Cut this off. Let's just make sure the other jack is fine as well. Just make sure it's working properly before we give it back to my buddy at work. Yeah, awesome. So I hope you liked this repair today. If you did, please like, share, and subscribe. I'm going to have some links down in the video description of some of these tools and items that I find helpful on my workbench. Any of those links you click on are affiliate links, and they help support the channel, and I greatly appreciate it. So thanks so much for watching, and God bless.